Welcome to the Unit 4 Lesson 2 notes. Go ahead, pause the video, work out these warm-up questions. Shouldn't take you very long. You just got to pick A, B, or C, which thing represents, or which picture represents the equation that you are given. So number 1, C equals 5 times N. So I would be able to quickly figure out that A is not the correct option, because if I'm taking N as the number for the box number, like it says, box 4 times 5 does not equal 2, so it can't be that one. And then I would also be able to eliminate B pretty quickly, because box 1 times 5 does not equal 2. That leaves C as the correct answer. Number 2, okay, you have nothing in box 1, so you would have had to have N equals 0, which isn't possible, so it can't be A. For B, okay, 1 times 3 is 3. 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. That looks pretty good. That's B is our correct answer. That was a horrible circle. C would not work because those numbers are getting smaller instead of bigger. So your answers are C and B. I'll actually highlight them so it looks a little bit more obvious what we picked for our answers. So today we're going to be solving percent proportions. So a hat costs $25. The sales tax on that hat is $1. What is the sales tax? We're still going to be setting up proportions. This time we're going to be comparing dollars and percents for parts to whole. So if I do dollars, it's $1 to $25. $1 is how much we paid in tax, $25 for the entire cost. The percent we do not know, but it is always out of 100. And you use a variable. I'll use X. So then you could use your horizontal method, multiply by 4, to get X equals 4. All right, they set it up slightly differently, just literally the order, and they picked a different letter. So they said let Y represent the first number in the percent ratio. So they did Y over 100. We did X over 100. Then it was the sales tax was part of the cost. The total cost is 25, and then they solve from there. So when you're doing this, you're going to have to be careful about a couple of things. Okay, they said use the horizontal strategy, like I said as well. Multiply by 4, you get Y equals 4. What I'm saying you need to be careful about is how you write your answer. So they said the sales tax is 4%. 4% is equal to 0.04 is equal to 4 over 100. Okay, is equal to 2 out of 50, is equal to 1 out of 25. These are all equivalent ways of writing the same thing. The question is asking for sales tax as a percent, so this is what you're going to use. In the future, you may end up having to use the fraction or the decimal form. That's what these things are going to be. You need to be able to go back and forth between fractions and decimals and percents. All right, so that was pretty straightforward. It's just a proportion. We've been doing proportions for a long time. The whole is always 100 when we're talking about percents, and the top number is always going to be part, so it's just a part to whole relationship. So for these 6 problems, go ahead and solve, and then I want you to actually give a label. Okay, if you're given, like for number 1, you're solving for the number of hours, so you're going to find what Y equals and write that number hours, or laps, or percent, and so on. Okay, I need a label for all of these. So pause the video, work through these 6. When you're done, unpause and see how you did. So number 1, what I'm going to do is I'm going to divide by 4 going from right to left. 24 divided by 4 is going to be 6. We need the label of hours. Number 2, I'm going to divide by 10 going from right to left to get Y is equal to 7 laps. Number 3, I'm going to multiply by 25 going from left to right. So Y equals 25, and then I'm going to use the percent symbol. If you wrote the word percent, that's perfectly okay as well. Number 4, I'm going to use the horizontal method to divide by 20. If you're like, hey, I didn't know I could divide by 20, that's okay. You'll still get 2 miles if you did it right. What you could do instead is simplify 40 over 100, divide top and bottom both by 10, gives you 4 over 10. That makes it a little bit easier. Divide top and bottom both by 2. It'll give you still 2 miles. Number 5, I'm going to use that trick this time. I'm going to simplify this fraction. 16 over 20, if I divide both of those by 4, that gives me 4 over 5 equals y over 100. You didn't have to do that if you didn't want to. I'm going to multiply by 20, multiply by 20 to get y is equal to 80%. And then number 6, I'm going to multiply by 2, multiply by 2 to get y is equal to 98%. This lesson is very, very quick, very short, because it's just repeatedly doing what we've already been doing. So next we're going to talk about the difference between absolute and relative change and solve percent proportion problems to find relative change. So compare the absolute and relative change in the height of these sets of 2 plants. So the picture below shows 2 plants and how much each one grew in the summer from June to August. The absolute change for each plant is 2 inches. Is the relative change the same? So there's a lot of words going on, but the absolute change is how much did it grow. This one grew 2 inches. This one also grew 2 inches. That's the absolute. How much did it actually grow? The relative change is how much did it grow as a percent of itself. So it grew, let's scroll to the next piece. Oh, sorry, thought I had another picture there. I apologize. So the relative change is not going to be the same. So think of this as if I was to stand next to a toddler. If I grew 1 more inch, you probably would not even notice. If a toddler grew 1 more inch, you would definitely notice because it's a big deal. Where this comes in my opinion, where it comes in the most often, is if you've ever noticed when people get haircuts. It's a lot easier to notice when someone with long hair gets their haircut because it's a more noticeable change. Okay, if they cut off a whole bunch. If they cut off 1 inch and I cut off 1 inch of short hair, mine's going to be more noticeable because I'm going to look bald. A person with really, really long hair cutting off 1 inch of hair, still going to have long hair. Maybe won't notice that as much. So the percent growth, we compare from the original. So this one started at 4 inches and then went to 6. So the change was 2, so I need to find a percent. So I'm going to take how much it changed over where it started. So it changed 2 inches and it went over, it started at 4. As a percentage, this would be 50%. Okay, multiply by 25 going across. For this other plant, it's still a 2-inch change, but this one started at 20 inches. As a percent, this is only going to be 10%. Just put a variable there. So is the relative change the same? No. This smaller plant had a greater relative change because this percentage is bigger than that percentage. All it's saying is this change would be more noticeable than that change. That's all relative change is doing. So on these problems, I believe we've got a few of them. So, or did this one double up? I can't remember. Okay, we got a couple problems. So for this first one right here, find the percent change for the situations in each problem, then compare the relative changes and tell which situation changed more. So a scientist has 2 beakers that contain different amounts of liquid. She adds 10 milliliters of water to each beaker. And this is part of the picture, it's just saying the same thing. This one started with 50 and this one started with 20. Find a percent change in the amount of liquid in beaker A by writing and solving a proportion. So we added in 10 milliliters, and beaker A started with 50. Compare that as a percent, something out of 100. Okay, to solve this, I'm going to get x equals 20%. I know that it's 20 because I would multiply by 2, going across that way. I do the same thing with beaker B. Started with 10, or changed with 10, started with 20, so 10 out of 20 equals a percentage. I can't use x because x is already being used in this problem, so pick a different letter. I'll pick y. I'm going to multiply by 5 going across this way. You could have divided by 2 going from bottom to top. That's going to be 50%. So which beaker had the relative change? Which beaker had the greater relative change? The relative change in beaker B was greater, because 50 is bigger than 20. 50% is bigger than 20%. So now I'm going to have you go through and do these 3 problems. They're a little bit longer. There's not a whole lot of space, but if you want, you can write off to the left side or the right side, wherever you need. So number 1, you can skip, because we literally just did that exact problem. Okay, it's the exact same problem. 10 milliliters, 50, and 20. Number 2, the questions are over here. This was in a book, so it's on different pages. That's why it's kind of messed up like that. And then number 3, you've got inches of snow. So go ahead, pause the video, work out number 2 and 3, and then see how you did. Okay, so number 2, Sarah and Kira are stacking coins, and they both add 4 coins to their stack. Sarah started with 10, Kira started with 8. Find the percent change in Sarah's stack. So Sarah added 4 coins to her stack of 10. As a percent, this is 40%. Okay, multiply horizontally by 10. Kira, on the other hand, added 4 to her stack of 8. Now this is one where you're going to have to do a little bit of work, because we can't just do 8 times something equals 100 very nicely. But 4 divided by 8 I can rewrite as 1/2. I can simplify that fraction, and then that's a little bit easier to do. Multiply by 50 going across. I get y equals 50%. So the relative change in the number of coins is greater in which stack? Kira's stack had the greater relative change. We're just looking at which percentage was a bigger number. So Kira's stack had the bigger number. Her change was more noticeable. Number 3, it snowed 3 inches in the mountains last night. There was already 10 inches of snow at the bottom of the mountain and 30 inches of snow at the top of the mountain. What was the percent increase in snow for the top and bottom of the mountain? All right, so find the percent change in the amount of snow at the bottom. That's the first piece. So we changed by getting 3 more inches of snow, and the bottom started with 10 inches. So that tells me if I multiply across from left to right times 10, I had a relative change of 30%. For the top, it still went up 3 inches, but it started with 30 inches of snow. And then this is like that last problem. I can't just take 30 times something to get to 300, but I can simplify. Uh-oh. That's not what you want to have happen. Sorry about this weird loading screen. Hopefully that doesn't mess too much up. There we go. All right. So, where was I? My iPad is freaking out. I apologize about this, everybody. I'm sorry. All right, so we are right here. Like the last problem, we can't just take 30 times something to equal 100, but I can change 3 over 30 to 1 over 10 if I divide top and bottom both by 3. Now multiplying across by 10, I get that y is equal to 10%. So for the first time, the second number is actually a smaller change. So the relative change in the amount of snow is greater for which part of the mountain? There was a greater change at the bottom of the mountain. right, so now your homework is lesson 2. So go ahead and take care of that, and hope everybody has a great day.